Okay, so in the last video, we just did the first part of 5.4, right? So we went over all the rest of the differentiation rules and we went over examples of differentiating given a base of E and given a base of B. And then we stopped it at number 2. So I'm just going to see how much, so I have another just one full page left because it does take probably about that amount of space, I would say. You might have a little bit of extra room, so you don't have to write super, super tiny. Okay, so for the function f of x equals x multiplied by a base of e to the exponent 3x minus 5, right? Tell me any critical points that you may have, points of inflection, intervals of increase and decrease, and intervals of concavity. So first is just taking the whole question in and seeing what it's asking of us. So for example, it's not asking us to graph or sketch anything. So we have no graph or no sketch. And I'm just going to kind of color, but when it talks about critical points and intervals of increase and decrease, that goes along with, so let's just say here refers to the first derivative, right? First to the first derivative. We've done this many times. So the first derivative is going to tell us if I have any critical points, and then doing our chart will tell us any areas of increase to decrease. And then we also have, let's say here, points of inflection that we might have, possible points of inflection and intervals of concavity. That would refer to the second derivative, right? So that's basically what I need to be doing, getting my first derivative and second derivative. So if I start here and I go back to my original function, what does it look like in terms of which differentiation rule am I doing here, right? So keep in mind that the first, right in front of the base of E here is not a constant, right? It is a variable. So it is one thing, if you will. Let's just make my line a little thinner. It is one variable, x, being multiplied by e to the base of 3x minus 5. So that hopefully that helps you to figure out that we would be doing the product rule here, okay? So let's start our f prime of x, getting our derivative. So the product rule is, again, the derivative of the first times the second plus derivative of the second times the first. So the derivative of the first, x, there's an exponent of 1, is just 1. Derivative of the first times the second part is e to the exponent of 3x minus 5 plus, for product rule, derivative of the second. So the derivative of just the second part, again, when you have e to the exponent of something, the derivative of it is to continue just writing e to the exponent, but then you need to take the derivative of the exponent. So then that would just be 3 multiplied by 3. And again, you could put brackets around that if you wanted to, multiplied by the first part, which is just x. So keep in mind that that x is coming from the first part. And then it's just cleaning it up, right? So I don't need to write down that 1 there. So I would just write down the base of e to the exponent 3x minus 5. I don't have any negative constants to change that plus, so that would stay a plus. And usually we put kind of the constant first, so the 3, and we can have the 3 multiplied by the x, and then that multiplied by e to the exponent 3x minus 5. And then we always kind of take a look around and see if there's any common factoring I can do. So I have this, if you notice, the e with the exponent 3x minus 5 are exactly the same. So if I factored that out, e to the exponent 3x minus 5, then what would I be left with for the first term? That's taking out the entire first term, so 1. And for the second term, I'd be left with 3x. So then that doesn't look too bad, right? So then for our critical numbers, I want to set that equal to 0. Right? So 0 on the left-hand side. Instead of rewriting this, I'm just going to throw the 0 there, right? Saves me a step, especially when we're writing out so much. So then we set each term, right, equal to 0. So I'm setting this side equal to 0 and this bracket equal to 0. So I have base of e to the exponent 3x minus 5 equal to 0. Solve for x, for my critical number. And I have 1 plus 3x equaling to 0. So let's say the right-hand side is easier. I might want to go ahead and do that first. X is going to be equal to negative a third, negative 0.3 repeated, right? So I know I have one critical number there. Now, how do I solve for x when x is in the exponent of a base of e? So what I should be doing is taking the ln of both sides. So if I were to take, just for example here, the ln of e is equal to the ln of 0. The ln of e, right, cancels out, and I have 3x minus 5, and then I would calculate what the ln of 0 is. So I can get a number and then that number plus 5 and then divide by 3. But if you remember from before, ln of 0 is an error on my calculator, right? It doesn't work. So then if I have an error, I can't take an error and plus 5. It just does not exist. So in this case, this portion of the equation of the function does not have a critical number. And then the good part is I only have one critical number, which helps me out for my chart, right? So therefore, I have a critical number of negative 1/3. So let me see. I can probably fit the chart here on this same page. So to do my intervals of increase and decrease, I found my critical number. That's where I do my chart. So if you remember, just moving up here, right, that I do my basically like a number line of positive infinity and negative infinity. And this is really the x-axis. And the only number I have a critical number of negative 1/3 there, right? I have to check back for restrictions. So this was not a quotient. There's no denominator. I have no other restrictions. That just didn't exist. So if it doesn't exist, I don't need to put it on. No vertical, horizontal asymptotes, anything else, right? So that's all I have to work with. Then I'm just looking at one side, the left side of it, and the right side of it for my chart. So if you remember, it's been a little while to do the chart. I have to write out the factors. Just trying to find where I'm going to have room here. The factors of the derivative, the factors of f prime of x, which would be the step when you make it equal to 0. So we're going to go back to that step. And my first interval is from negative infinity to comma negative 1/3. And then my second interval is starting at negative 1/3 to positive infinity. And that's all I've got. So my chart isn't going to be, luckily, all that big. So again, my factors, the one side would be e, base of e to the exponent 3x minus 5. That's one factor. And the other factor is the 1 plus 3x, whether you want to put that entire thing in brackets or not. The math is the same, so that's up to you. Then we have our overall sign, right, of the derivative. And then we have whether our answer, are we increasing or are we decreasing, but over the original? Is our original function increasing or decreasing? What information did we get from completing this chart? So just know that this overall sign is for the derivative, just to add that in there, right? And the increase decreases of the original. So now we just have to pick some values and fill out the chart here. So let's say between negative infinity and negative 0.3333, negative 1, right, is smaller than that number. So that would work. So if I have 3 times negative 1, negative 3, subtract 5 is e to the exponent negative 8. Go ahead and plug that in on your calculator. E to the exponent negative 8 is going to be a positive. So the overall result there will be positive, okay? And then here, 1 plus 3 times by negative 1, 1 minus 3 is going to be negative, right? So my overall sign, multiplying these two together, is negative because I was multiplying these two together. So then I am decreasing over the original function. The overall function is decreasing along that interval. So again, between that negative 0.3333, so I'm negative to positive infinity, 0 would work or 1 would work. So if I have 0 here, I just have e to the exponent negative 5. And again, if I were to plug that in on a calculator, it would be positive. So my answer is positive. 0 times 3, 1 plus 0 is 1. That'd be positive. So my overall sign, multiplying those two together, the derivative, the overall sign is positive, which means that the original function would be, because it's positive, I am increasing. And now for my conclusion of this, I'm going to clear the screen. Actually, I'm just going to erase this because I don't want to clear the screen and talk about it when it's not up in front of us. But so just know that I'm just going to erase a part of this side here, just so I can make a conclusion there, and then we'll move on to the next page to do the second derivative, right? So we already have our answers down for that. So what would our conclusion be here? So if I was decreasing, right, and then I'm increasing, and this is a critical point, right? The critical point of one right here, critical number of -1/3, because that is a critical point and I'm decreasing then increasing. So I've got a smile, then you can see that I have a local min, right? So I have already way down here, if you can see, I've got a local min, but then I need to find the y value of that, right? At x equals -1/3. In order to get the y value, you always go back to the original. So I have a local minimum at, if you wanted to rewrite it, again, if you were on a different page, I would rewrite it so that also when I'm marking, you can see it, which probably you would be because you wouldn't be erasing this, right? You probably wouldn't fit this in. But because I have it right up here for this particular one, I won't rewrite it. So at f, and my x value is right there, -1/3. So f at -1/3 is equal to, when I see x, I put in -1/3 multiplied by e to the 3 -1/3, all as an exponent, bracket -5. So I'm going to go ahead and do that first. So I would have -1/3 multiplied by e to what power? So that multiply across the top and bottom, right? So -3/3 is -1. -1 subtract 5 is -6. We already know when I'm at around -8, -5, it's a positive answer, right? And so I could turn that whole thing into one actual number for a y value, or I can just write it as, I don't want a negative exponent, so I would bring it down into the denominator. So I'd be left with just -1 on top over 3e to the power of 6. Positive 6, don't forget. -1 over 3e to the power of positive 6. And therefore, I would have, I'm just going to put that in the middle here. I think I have room. So therefore, my local min, right, just double check it is a minimum. That's the lowest point. My local min is at the xy coordinate point of -1/3 first, and then -1 over 3e to the power of 6. Now just be careful again. This isn't the final step, but when we're checking with the back of the book or a worksheet that you have, that could be the answer. Or again, if your answer doesn't match, did they just take this and turn these into numbers? Like it might say -0.333 and then a number there as well, right? So just take a look at whether they've computed it and how far they've gone. So next step, we've got our local min, right? So now to figure out if I have any possible points of inflection and intervals of concavity, I'm now going to rewrite the derivative again on the next page and then get the second derivative. So to rewrite that derivative, which is the same, anytime you're switching a page, I would like you to do that for me as well, because it's hard to follow. If the more I'm jumping around, maybe I could make a mistake in marking you too, right? Because I'm going back and forth. So it was e to the power of 3x minus 5. Just double checking that I did write it right. E to the power of 3x minus 5. Plus. I don't have a plus here. Oh, I see. Okay, the step where it equaled 0. Okay, I'm getting them to match up now. At first, I couldn't find how. I thought I had maybe wrote it down wrong, but I see that they're the two equivalent squats now. So yeah, just double check that the first derivative is e to the power of 3x minus 5 multiplied by 1 plus 3x, right? So again, I have two terms here, multiplying happening between them. So I'm going to do the product rule to get the second derivative to differentiate. So the second derivative is derivative of the first. So now be careful here because the derivative of the first is just copying the first one down, but then getting the derivative of the exponent, which is 3, then multiplying that by the second part just the way it is, then throwing a plus sign in there, then doing the derivative of the second, so that'd be 0, and that's 3, so just 3, multiplied by the first, just copying down the first. And then it's always cleanup time, right? So cleanup time, you usually put the 3 in front, and we usually kind of just have the base of e last, if you will. You don't have to, but I have then the 1 multiplied by 1 plus 3x multiplied by e to the power of 3x minus 5. Check the plus, there's nothing changing it to a minus. And I just write it out maybe together without the bracket, really. Then take a look at any common factoring that I can do. I don't know until I take a look. The 3 is common, and the e to the power of 3x minus 5 is common. This is not. So I can pull out some type of common factor. So I can pull out the 3e 3x minus 5, bracket what's left of the first is bracket 1 plus 3x. And then everything's taken out here, but you have to fill in the spot with a 1, right? And then to clean that up, I've got 3 multiplied by e to the exponent 3x minus 5. This is the same thing as just 1 plus 3x plus 1. So that would be multiplied just by 3x plus 2, because we usually put the variable first, right? And the coefficient last. And once I've gotten my derivative down as far as I can go, that's what I have here, is I set it equal to 0, right? And then I solve for x. So here, again, I'm putting this side equal to 0 separately and this side equal to 0. So I have 3e to the power of 3x minus 5 equaling 0 and 3x plus 2 equaling 0. Now, I'm hoping this one rings a bell to you. If you go back to the first derivative, we had the same thing. We had e to the power of 3x minus 5 equaling 0. And if you remember, when I got the ln of 0, it didn't exist, so I couldn't get a critical point at that time, an x value, and I can't here either because the 3 is just a constant, right? So setting it equal to 0 isn't going to change anything. This is exactly the same, so this side does not exist. And so then here I would have 3x equaling negative 2. So therefore, I have a possible point of inflection at x equals, be careful here, negative 2/3. I just put, divide by 3, divide by 3. Negative 2/3. So in order to figure that out, I have to set up my chart. And this one I am going to do on the other page. So I'm going to take that negative 2/3, right, as part of my chart. Again, there's no other restrictions or anything. We're almost there. Just the chart and then our conclusions. So I have my x-axis that I'm writing out just to help me get an idea of how many columns my chart is going to be. Just to visually see this in front of me is helpful. And I have my possible point of inflection at negative 2/3. And I don't have to put x because I said it was the x-axis there, right? I have no restrictions. So again, the nice part is I only have 2 intervals here to check for concavity. So going back to setting up my chart, I would have the factors of, now we were doing the second derivative here. So the factors right at the step when it was equaling 0. And then I have my one interval as from negative infinity to negative 2/3 now, be careful. And then from negative 2/3 to positive infinity. And then I just be careful what my numbers are there. So my factors when it equaled 0, I'm just going to rewrite that for you. was 0 equals 3 base of e, 3x minus 5 is an exponent multiplied by 3x plus 2 when we set it equal to 0. So then I have my one factor as 3e to the exponent 3x minus 5, and the other factor as 3x plus 2. Then I have my overall sign, but again, that's the overall sign of the second derivative, right? And then that answer is going to tell me whether I'm concave up or down now. Up slash down over the original function, f of x. Now I just pick out some values that make sense and see what my conclusions are here. All right, let's see. So this is again negative 0.6666. So negative 1 is smaller than that, is headed towards negative infinity. So again, this would be negative 3 minus 5. So it'd be 3 multiplied by e to the exponent negative 8, right? Which would be 3 multiplied by a positive. So that result would be positive. I don't really care what the number is. You can get it if you'd like, but just 3 multiplied by what I know would be a positive. And then here I'd have negative 3 plus 2 would be a negative, right? So my overall sign multiplying those two, because I was multiplying these two, is negative. Positive times a negative is a negative, so I'm concave down. Okay. Again, this is negative. So if I picked a value of 0 or 1, that would work. So again, if it was 0, it would be 3 multiplied by e to the exponent negative 5, which is again 3 multiplied by a positive. So the result would be positive. This is 0, so 0 plus 2 is positive. Multiplying those together is positive. So then my result here would be I'm changing to concave up. Now this is a possible point of inflection, right? So because I'm going, let's say, concave down, frowning, right? And then I'm going concave up, smiling. So changing from concave down to concave up, that twist there is a point of inflection. So therefore I have a POI, a point of inflection, that does confirm it at x equals negative 2/3. Now I need my y value. I'm going to plug that into the original. So therefore I have a point of inflection, right, at f at the x value of negative 2/3. Now I don't have the original equation anywhere here, so I should probably write that down. F of x equaling x multiplied by e to the exponent 3x minus 5. Sorry, that's a little squished in there. So then when I see x, replace it with negative 2/3. E 3 multiplied by negative 2/3 minus 5 is negative 2/3 to the base of e. Negative 6 divided by 3, right, is negative 2. Negative 2 minus 5 is e to the exponent negative 7. So that could be my final, or again, I could turn that into an actual, just one numerical constant value. Just depends on what the back of the book is showing you. If I want to leave it like that, though, I would do the same thing as I did before and just have the negative 2 on top, right? The 3 is the denominator, and bring that e down. So I can make it to a positive 7. It doesn't look so bad either. So negative 2 over 3e to the exponent of 7. So therefore, my point of inflection, because I know I have one, is at an x value of negative 2/3 and a y value, of negative 2 over 3 multiplied by e, base of e, to the exponent positive 7 there as the denominator. And there we go.